Very good evening, Lakshmi. How are you, Lakshmi? I'm also fine. Thanks for asking. It's already 5 minutes. Why not everyone is joining? Good, okay. Let's wait for 2 minutes more, then we'll start with the class, okay? Very good evening, Benny. How are you? Very good evening, sir. Okay, then, so let's just continue with the class. I guess no one is going to join now. So let's start, okay? So it is going to be, I guess, fourth session on the same chapter, that alcohol, phenol, and ether part. So let's just start. Let me just give you a quick brief about the previous class. So in the previous class, we discussed about the last topic, that was the cumene preparation. It means that you will be having a some kind of benzene simply, okay? And then in this, we are adding this thing, okay? And then electrophilic substitution reaction is going to take place. This one we are getting, and then we are going to follow the aerial oxidation. Okay, it's a aerial oxidation, and then we are getting that like this, and further it is converted into the phenol and acetone. Okay, so this is the last reaction we discussed there, that is a preparation of alcohol or the phenol from the cumene there. So in the preparation part, every preparation point is done now. So in today's class, the topic of discussion is going to be the physical property. And in physical property, we are going to start with the boiling point and melting point. As you already know, like if we are using this word boiling point and solubility part, so obviously the first thing strike in everyone mind, that boiling point is directly and directly connected with the size. Right? For example, if let's suppose we are talking about a boiling point, so boiling point is directly proportional to the molar mass. Like how about the molar mass, like its maximum or minimum, and this is directly proportional to the size as well, and this is directly proportional to the that surface area simply, you can say. Okay, so more is the surface area, higher will be the boiling point, you can say. So let's just drop this, okay, surface simply, and just write here like linear chain. You can say that as a linear chain has a more boiling point over the branching one, and it is inversely proportional to the branching. More is the branching, lesser will be the boiling point, so branching is there. And okay, this is all for the boiling point there. Now, for example, let's discuss a question. Like, as we know, boiling point is directly proportional to the number and size and all these things. Okay. Now, like let's compare how to understand this. Like, as we know, branching with the branching, the boiling points are decreasing there, right? For example, like this is a question for you. You have to identify which of the following has a maximum boiling point. Okay. So, like the increasing order of boiling point. This is a question. The increasing order of boiling point. Okay, so you have to arrange them of alcohol, obviously that is normally alcohol there. Okay, and then option number one, it is going to be the 1,2 dihydroxy, and I hope now you're familiar with the name, so it's a dihydroxy benzene. Second is going to be the, that is a 1,3 dihydroxy benzene. And the third is that 1,4 dihydroxy benzene. And the last is going to be the hydroxyl benzene, okay? This is a question for you, okay? So I know maybe like you be like, ma'am, you're explaining something, but you're arrange the following in increasing order. I will take your doubt at the end, Darshana, okay? Very good evening, Darshana. Yes, please. According to you, what will be the order? So you said that is a tertiary, then secondary, and then primary. Okay. So do you know the reason as well, Darshana? Like why this is the order? Clause packing. Okay, you're right. But like according to the clause packing, then why not according to you the two has maximum? My question to you like why not one? Like why the options are, I guess you are saying para, then meta, then ortho. Okay, Mini. So let's try to understand the actually what will be the answer for this question. Okay. So in this case, listen. First of all, as you know, the packing point is really important there. Like if you to go with the para. Okay, so what is it? It's nothing. It's a 1,4 dihydroxybenzene there. So in this case, if you're observing, we are having both the OH group just opposite to one another, right? So definitely in this case, we are having a perfect packing, and this one is going to be the maximum boiling point there. Okay, so you can see the para one is the maximum. But now, like in between 2 and 3, so why the second has maximum over the 1? This is my question, okay? So let's try to understand this point here. For example, that if you are having 1, 2 hydroxybenzene or this one. So answer line is some a very much important concept if you know. Yes, please. Like why not this one has a maximum? Like why this is the order? Okay? Okay, Darshana. There is a very much important phenomena if you know. You know the hydrogen bonding? Which kind of hydrogen bonding is there? Okay, so in this case, what is the extra point here if you're observing that these OH, okay, let me just write the OH like this. So in this case, this is a OH group simply, and this OH group form a kind of hydrogen bond with this, okay? So, but like, just try to understand if let's suppose this OH participate in a hydrogen bonding with another benzene, like this is a common thing in both the cases, like this. In this case, I'm saying, okay. So in this case, look at this benzene. This benzene automatically has inside hydrogen bonding. So it's not going to participate or like willing to form any extra bond with the side molecule. So obviously, what is the real meaning of boiling point? We are breaking the bond between the molecule. You know, if let's suppose I have to write this is water, so definitely I'm not going to break these bonds. So what is actually the boiling point means that this weak wonderful force of attraction between two water molecule. So in this case, if like molecule not have any kind of bond with other molecule, then how we are going to say like this one has a maximum boiling point? So that's why that after the para, the next one is going to be this. Like what is the correct order? Then okay, let me just write here 3, then 2, and then 1. Then at the end, that's going to be the 4 there. Okay, so okay, sorted. Now why the 4 at the very end? Yes, please. Why 4 at the very end? What would be the reason then? Number of carbon, right? See, or you can say the mass, atomic mass, or the molecular mass simply, right? Yes, of course, less molecular mass. So that's why this is all for the question. So hence, I hope this question is clear for everyone. Like how about the concept here? Now, if you to compare the alcohol with the normal, let's say that organic compound, so we can say that alcohols has maximum boiling point as compared to the ethers, or as compared to the that alkyl halide part, the thing which we already covered. So then can you just tell me like how it is possible? Again, the common thing, or like any organic compound you can say, any hydrocarbon. Can you just justify the statement that why this is the statement? Of course, hydrogen bonding, right? But is the plus point with the alcohol because they are having a OH bond, and of course they are going to participate in a hydrogen bonding, right? So that's why this is the point. What will be the reason for this question, or like for the statement? You can simply say that is a hydrogen bonding in alcohol. Okay, hydrogen bonding in alcohol. So same, you can go with the solubility part as well. So let's just see the second statement that, sorry, the second factor here. Look at the solubility. Again, that you are going to follow the funda that is like dissolve like. So according to that topic, you can say solubility wise, alcohol is very good soluble in water as compared to the organic compound. Okay, so how about the solubility? Since alcohol is a polar simply, okay, so alcohol are polars. So it's a polar in nature. Then what is going to happen there? Obviously, that is a strong force of attraction. And one plus point as well, like hydrogen bonding. Let me just write here. Hydrogen bonding and strong force of attraction between solvent, between alcohol and a solvent. Why? Obviously, then we are going to use like water. So what is the plus point? Hydrogen bonding can be there. So this is how you can justify simply. And again, like solubility wise, alcohol is much more soluble in water over the alkyl halide and the same hydrocarbon there. Okay, now answer this question, please. This is a question for you. In which case hydrogen bond is maximum? Okay, options are option number one, water. Okay, or the option number B, that is it's ethylene glycol. Or B is D2O, deuterium, and C is H2O2. Please answer the question. It's not like this is a question for the like hydrogen bonding or the alcohol. So alcohol is definitely the answer, okay? So in which case we are having maximum hydrogen bonding? D2, okay, Darshana. Yes, how about other? What do you think about it? Oh, oh, just wait, just wait. I have to change the options, right? Weird option. It's going to be the A, B, C, and D, okay? I'm sorry for this. Yes, please. Okay, then if I'm using water and H2O2, so which one has a maximum boiling point? Yes. If you're using water and H2O2, which one has a maximum boiling point? Okay, many ethylene glycol. H2. Okay, listen my question. there is a OH bond and there is a carbon oxygen bond. Okay, so let's try to understand actually what I want to ask here. Listen, first of all, what is ethylene glycol? I hope everyone you know now. And yes, of course, you're revising the common name according to me. So it's going to be the ethylene glycol, right? So definitely in this case, we are going to get that is a 2H bond there. Okay, now let's compare the strength. Here you're having a carbon, oxygen, and hydrogen, right? And like carbon, oxygen, and hydrogen. First of all, let's compare with the water. Like if you have to compare with the water simply, so in which case we are having a maximum hydrogen bonding. Like you have to select the water or the simple alcohol there. First, this answer this question. In which case we are having maximum? Yes, Mani, it's going to be H2O2. Yes. Between A and B, like water and alcohol, which one has a maximum hydrogen bonding? Second, okay, let me just give you a kind of like case. Listen, in this case, this OH participate in hydrogen participate in bonding. In this case, O participate in hydrogen bonding, this is also participate in hydrogen bonding. But look at this, in this case, the carbon is not going to participate, only H is going to participate, okay? This is how we are able to like differentiate, like in alcohol, we are having maximum bonding or water, right? There's an extra point, H is also present there, so definitely the water is going to be the maximum one. Okay, so this is how we are able to eliminate it. The ethylene glycol is not the answer here. Okay, so after this, like if ethylene glycol is not the case, so let me just remove this. Okay, now between water and D2O and like this H2O2 there. So first of all, let's compare between water and D2O there. So between water and D2O, like what will be the answer? Hydrogen and deuterium. Okay, and then second one, hydrogen and okay, just use D and D. So my first question to you, between hydrogen and deuterium, which one has a small in which one is smaller in size? Again, it's 11th class like kind of concept. Like between hydrogen and deuterium, which one has a small size? You know the basic criteria for the hydrogen bonding, small size and high electronegativity of the atom have to be there. Yes, please. And some of you like, ma'am, deuterium is not going to participate in hydrogen bonding, but because it's a D, right? But no, it's going to participate. Small size. No, my question to you, between hydrogen and deuterium, which one has a maximum? Sorry, that is a smaller in size. So listen, my point. This is two topic. Okay, like what is the problem with the student, ma'am? No, no, no. Listen, that mass wise, or you can say deuterium is heavy. So you can say simply D is heavy over the hydrogen. This is the point number one, that deuterium is only heavy. But if we are going to about discussing about the size there, so size wise, the hydrogen size is maximum over the deuterium. Okay, so it's a size order. So simply I can say that is a D2O has a maximum hydrogen bond over the water, right? So this is how we are able to differentiate between a D2O and then H2O2. Let's compare between H2O2 and D2O there. Okay, so now uh, try to understand again. You know, we are going to compare the same thing. Okay, like this is a normal question. Like banana is important, orange is important, or apple is important in day-to-day life. So which fruit you want to select? Yes, please. Which fruit you want to select? So you are going to say, I guess, every fruit is important, right? Everyone has their own importance here. So like if let's suppose in the previous one we are comparing between the water and a D2O there, okay, like this. So we are comparing the number like simple size. But now if we are comparing between the D2O, like maybe this question, ma'am, you just said that deuterium and hydrogen is small size, but how you are comparing with H2O2? So now in this case we are going to compare the extra bond. Right? So in this case, how about the hydrogen bonding? Oxygen the same. Deuterium, hydrogen is the same. Deuterium again, hydrogen is the same. What is the extra point again? Look at this. This is the extra point here. Right? This is the extra point here. So now, which one has the maximum hydrogen bonding then? H2O2. Okay, so this is a very important order. Okay, that we noted. If we are comparing the hydrogen bonding, so what will be the order? That first of all, D2O, sorry, H2O2. Let me just write the order properly. Okay, so look at this. That in this case, the order will be H2O2 is a maximum hydrogen bonding, then D2 is going to be the next one, then water is going to be the next one, and then this ethylene glycol one. Okay, but let's suppose, let me just change the question. My question to you, between ethylene glycol and glycerol, now which one has a maximum hydrogen bonding? Okay, H2O2, because in this case we are having extra hydrogen bonding, Darshana, that's why, right? See, between water and D2, we are comparing this as because the order is same, two hydrogen and one oxygen. But if you're to compare with H2O2, glycerol, I said glycerol. Yes, please. Let me just write what I'm asking. Which one has a maximum boiling point? Like options are ethylene glycol or glycerol. It's a glycerol. Glycerin. So that glycerol. You know the structure? Okay, the main thing is what you know the structure. Otherwise, the question is easy. So, in which case we're having maximum hydrogen bonding between ethylene glycol or glycerol. And just go and search, right? I'm assuming you already know the structure. Okay. No, no, no. In hydrogen bonding, we are not going to cover the like carbon there. Okay. So maybe I guess you were saying like, ma'am, if you have to consider carbon, OH, and hydrogen, right? And like this. So in this case, like if you have to compare between the normally that wait, hydrogen, oxygen, and hydrogen. But see, this carbon is not going to participate, and carbon is being like a little bit non-polar point there. Okay, so it's going to hinder the hydrogen bonding. Are you getting Darshana that why H2O2 is the maximum one? Okay, so here the carbon and carbon is not like participate in a hydrogen bonding. Yeah, you can say like because of the partial negative and positive charge, there's a polar kind of point there, but carbon is the different point here. Okay, Darshana. Yes, between ethylene glycol and glycerol, just compare this. I just want to convey you that normal alcohol is has a less hydrogen bonding over the water, right? Okay, then I guess you are not going to respond. Okay, let me just write the structure then. So it's normally the ethylene glycol, and what about the glycerol? It is a CH2, CH2, NOH, NOH. Okay, and this is CH2OH, CH2OH, and CH2OH. One hydrogen less. Yes, please. Now, I guess it's easy, right? Wait, this. Now I'm explaining. Just wait, okay? Okay, yes, very good. So I guess now you're able to understand like actually what is the simple thing we are going to compare when we the question ask about like boiling point or like solubility point there. Okay, so let me just explain one more time. Look at this. This is H2O2. Okay, and there is a one more molecule of H2O2. Similarly, that you will be having this. So in this case, like if you to go with the hydrogen bonding, like this oxygen participate, or let it just understand like this form a bond with with this hydrogen, this form a bond with this hydrogen, this form a bond with this hydrogen, or this form a bond with this hydrogen. Okay, and one more point, that is oxygen also has a lone pair. Okay, first answer this question. Maybe you don't know, or maybe you know. How many hydrogen bond present in water? Then maybe you are able to understand my point. The number of hydrogen bond in water, four. Then how you're saying it's a four? Because according to the concept, only one oxygen and two hydrogen have to be there. But how a water form a total four hydrogen bond, right? Yes, everyone you're right. But how it is possible that four hydrogen bond within the water? So I guess you are saying that hydrogen, hydrogen. Okay, so like one with this. Okay, one with this and one with this. Right, Darshana? I'm asking about water, normal water, plain water, okay? Yes. Okay, but is the actual point here? Do you know that oxygen has a capacity to form four bond as well? Why? Because there's a two lone pair present. So okay, that is one lone pair participate in hydrogen bond, but how about the second lone pair? This is also going to participate, right? So you are saying that is in this case we are having total four hydrogen bond. Now let's try to understand in this case. Let's just compare between this again. That here you're having a one lone pair and hydrogen. Okay. So in this case, one lone pair and hydrogen. So let's count the number of hydrogen bond. Okay, Darshna. So let me just count first for this. That one, two, three, and four. Okay, one, two, three, and four. In this case, one, two, three, four, five. Okay, wait. One, two, three, and four. And like again, one, two, three, and four. One, two, three, and four. Okay. Again, one, two, three. In short, that is this molecule have total eight bond. Okay. And in this case again, if you have to count, that is four, one, two, and three, one, two, and three. Total six bond, hydrogen bond. I hope now this point is clear. Like why not ethylene glycol is maximum one? Because here one carbon is connected, right? Darshan, try to understand. But there that oxygen connected with one another. So there's a plus point that one oxygen connected with another oxygen. Right, Darshana? Okay then. Good then. So I hope it's clear now. That's it. This is all for the solubility. Now let's start with a very interesting point or very important point as well. Let's just talk about the chemical property of alcohol. So like in this alcohol, we will be having a choice. Okay, choice means that if let's suppose this is a alcohol there. So you know in this case this bond is typically polar, right? In this case, yes, okay, you can say this oxygen has a negative charge and this R has a positive charge. But still this hydrogen also has some kind of like polarity as well. You can say this hydrogen simply have some positive charge as well. So the point is what? That you can break the bond from here as well or from there as well. Okay, so two things. Let's just suppose in this comparison, we are just going to compare between, first of all, the breaking between R and H bond. Okay, now my question to you, what is the first property you want to assign if let's suppose I have to break this bond? So like options are acidic character, basic character, neutral character, like which thing? Like how this bond breaking explain acidic characteristic or basic, like what is the point here? So ROH give the H positive ion simply, right? So then acidic character, right? So it means now we are going to compare between the acidic characters, right? Yes, very good. Okay, so now next question for you, that if let's suppose I'm having a normal alcohol, okay? Let's suppose aliphatic alcohol, let's just use some examples. So it means our first topic of discussion of the today's class is what? Acidic strength. Normal, simple, sorted, that is the acidic strength of alcohols. Okay? So between alcohols, right? That simple. Like if let's suppose this is a some CH3, okay, and it is connected with some NO2 group. Okay, this is a simply. Okay, in the second one, that is if let's suppose I'm having simple CH3NOH. So in which case you are the which alcohol is maximum acidic in nature, A or B? Find the acidic strength simply. Okay, first just try to answer this, then I will give you a brief like how to compare the acidic strength. Okay, just first recall the memories of the 11th class, then we are going to proceed with this. Yes, please. According to you, between A and B, which one has a maximum acidic strength? Was this that much difficult? Okay, Darshana. Okay, Niharika. Yes, you're right. Okay, so yes, very good, Mini and Niharika and Darshana. So you're right, option A is going to be the correct. Like this one has a maximum acidic strength. But why? Right? This is the biggest question now. So listen first of all that what is really going to happen. So let's start with a basic concept of a chemical equilibrium that if you're having some acid, this is HA, right? Acid is going to break into the H positive ion and A negative simply. Okay, listen my point. Just think about it that this is a reactant and reactant convert in the product. So what is the biggest factor for the conversion of reactant to the product? Like why a reactant want to convert into a product? Yes, you're right, Niharika. Yes, please. That why a reaction is going to process, why reactant is going to convert into the product. Any reason? Do you know? Obviously, it's a chemistry and everyone wants stability, right? Stability. Then how the stability is there? So think about it. If let's suppose I'm saying in this case simply that okay, this is acid and this is going to break. So definitely that if this reaction is going to happen, so what is it? This is normal acid simply, right? And what is it? It's a conjugate base. So what is the key point? That our conjugate base have to be stable. I said that it is going to be the stable one. Okay, so it means this is not stable. No, it's not stable. Okay, so this is stable and this is unstable. This is the point number one, stable or unstable. Okay, it means our acid is not stable. Okay, then. And when someone is not stable, so obviously that is going to participate, reactive. You know, that let's suppose you are having a so much energy and there's a fight is going on. Obviously, you're going to participate in that fight, right? But on the other hand, your battery is low, okay? You'll be like, no, just leave them. Okay, I'm not going to participate in the fight. So same here. The unstable is what reactive, very much eager to do the reaction there. But on the other hand, if something is very much stable, so stable will be like, no, I'm chill, okay, I'm not going to react. So it's non-reactive there simply. It is a non-reactive. Okay, so non-reactive you can say. But okay, but how the thing is related with the acidic strength there? So it means that our main agenda for the acidic strength is what? Just to check it the stability of this A negative ion. Like, is it stable or not? And what is this? Conjugate base. And since this is equilibrium I am representing here, so let me just write that is it's going to be the some Ka value. Like Ka means A for acid, K for equilibrium constant. So what is it? It's a equilibrium constant. It's a equilibrium constant for acidic, okay, for acid simple. Okay then, so how to write the Ka value? Wait for a while, I'm erasing this. Okay, so now you know very well that how about the Ka value, that it's a simple chemical equilibrium topic, that K is equal to the product concentration divided by reactant concentration. How about the product? That this side you will be having H positive and this is A negative and it's divided by Ha there. And obviously we know this very well that Ka is directly proportional to the H positive, and obviously means more is the Ka value, higher will be the acidic strength. Okay, now next pKa value. So be noted that is what is pKa? pK is equal to the minus of log of H positive ion. So you know this negative itself clear this point that negative means inversely proportional. So let me just write here that what is the simple conclusion there, that Ka is directly proportional to the acidic strength. Okay, but it's inversely proportional to the pKa value. When you're solving the question like this, always write pKa, pKa, okay? Always mark the whether the question asks about Ka value or pKa value. It will be very helpful for you for solving the questions. Okay then. Now the next thing is what? That how to check it for the stability. So let's discuss an example. Like again the same concept. You will be having CH3 and this is O negative H, right? Yeah, this is OH. So now hydrogen will be like, I'm willing to live. Oxygen will be like, you can live. I'm negative charge. I can easily handle the negative charge. Okay then. Now the second topic which we just discussed, that example and note is there. So in this case, that hydrogen will be like, oxygen I'm going to live. So oxygen will be like not an issue because I'm having a carbon. Carbon is already connected with electron withdrawing group. So what is it? Electron withdrawing group. What is the main agenda of the electron withdrawing group? To pull the electron density. You know what is this negative charge representing here? Extra electron. And we know that electron is never ever stable. Whether the charge is negative or positive, extra electron or the deficiency of electron is not good for the molecule. So it's an extra electron there simply. Okay, so B noted, negative charge is simply stabilized by electron withdrawing group. So we can write that if we are checking for acidic strength, we are checking for A negative stability, yes. So that acidic strength, if we are checking for the acidic strength part there, so how about the acidic strength? It's a directly proportional to the that electron withdrawing group. In short, that if we are going to discussing about the factor, it is directly proportional to the minus I effect, it is directly proportional to the minus M effect, it is directly proportional to the, it's a M, okay, it's a M simply. Okay, it's a M, it's a minus I, and it's a minus H. Okay, maybe you already know the reverse hyperconjugation, maybe you already covered in 11th class. Okay, and these are the direct proportional. Then how about the inversely proportional there? That is electron donating group. Okay, or inversely proportional to the plus M, or inversely proportional to the plus I, or you can say it's inversely proportional to the plus H as well. So this is simple single slide to explain the acidic strength of the molecule. Okay, this is the point number one. These are the things we are going to check normally for checking the acidic strength. Okay, then. Now answer this question again. That is a question for you. This is the OH. Okay, point number one. Or this is the OH. So which one has a maximum acidic strength between A and B? Yes, please answer the question. Which one has a maximum acidic strength here? Check every factor, okay? You know, that is all, not only the electron donating we're doing, there is some other concept as well, right? I will explain, just wait, okay? Okay, Darshana. Do you know the reason as well? That why? Resonance. Yes, you're right. Okay, so let me just quickly explain what is happening. In this case, if let's suppose you will be having a negative charge, it's a conjugate base, so it's much more stable or normal. This, right? Why this is a reason? Because obviously that in this case there's a resonance take place. Hence, that it is an extra factor for the normal, that stability there. Wait. Okay, so this is a double bond simply, and here you will be having a negative charge like this. Okay, so what will be the correct answer? This is more acidic over the B. A is more acidic over the B. Now you ask about the reverse hyperconjugation, right? So what is the meaning of this word? That is a reverse hyperconjugation. Okay, so listen, that for example, just try to understand if this is a normal benzene and it is connected with carbon, hydrogen, and hydrogen, and hydrogen. But on the other hand, if let's suppose this is a benzene and this is a carbon, it is connected with some chlorine, chlorine, and chlorine. Okay, so in this case, that you will be having alpha hydrogen. In this case, you will be having a alpha halogen. At least one alpha halogen is the key factor for the reverse hyperconjugation. So this is our normal hyperconjugation. Okay, and this is reverse hyperconjugation simply. Okay, so let's try to understand actually what is going to happen in this case. Listen, in this case, this hydrogen form like breaking a bond. Here you will be having H positive simply, right? Let me just break this like this. This hydrogen has a positive charge and carbon got a negative charge, and this carbon double like negative charge transferred to the benzene. Okay, so let me just write in a single way that like actually like in one step simply, that this is a hydrogen there and hydrogen simply transfer the bond, and look at this, the like this side, A side. But on the other hand, what is really happening here, look at this, that this carbon chlorine bond is going to break. You know, chlorine be like, I am negatively charged. Okay, so the chlorine going to take the negative charge from the carbon, and carbon achieve a positive charge, and now see this double bond simply participate here. So see the difference, that in this case if you have to observe that double bond or the electron density is moving toward the carbon. Okay, but in this case, that is the electron density is moving inside the benzene ring. So it's like a plus M and minus M. That minus H is nothing, that when At alpha position, at least one single halogen group is connected, so it's become normally that is a reverse hyperconjugation. Okay, Darshna. So this is reverse hyperconjugation. So let's just back again. This is all for the point. Now, okay. Now compare between alcohol and phenol. So can you just tell me between alcohol and phenol, which one is more acidic in nature? Which one is more acidic in nature between alcohol and phenol? Okay, no need to say thank you. But yes, please answer this question. Which one is more acidic between alcohol and phenol? Phenol, right? Why the answer is phenol there? Because in this case, that if you're having alcohol there simply, okay, or other on the other hand, if you will be having a benzene, you know, phenoxide ion. Look at this. In this case, if it this bond is going to break simply, so this is a negatively charged, and in this case, the resonance is the key point here. That resonance is going to be the reason behind the stability. So be noted that phenol most of the time has a maximum acidic strength over the alcohol. Okay, I hope this point is clear for everyone. Yes, you are right, the Shika. Okay, now next question, please. Plus K effect. Plus K means oh plus M. Oh yeah, you're right. Okay, so now answer this question, please. It's also important point that you have to identify the acidic strength order. Okay, like arrange them in order simply. Okay, acidic strength. So like you will be having ortho nitrophenol, para nitrophenol, or that is the meta nitrophenol, or the last one is what? Only phenol. So arrange them in a acidic strength order, okay? Increasing, decreasing, whatever you like. Okay, yes. Para, then ortho, then beta. Okay. Okay, you said C, B, A, and okay. You know, this is one of the famous exception of the acidic strength, but still you don't know the answer. Again, it's a very famous phenomena. That will be the reason behind the exception. But what is the phenomena? Okay, so let's try to understand this question. The correct answer will be that is first of all B, and then C, and then A, and then D. Okay, so this is the correct answer here. Let me just check. This is the answer. B. Why you are saying C? Okay, so let's try to understand the question basically. So what I want to ask, if let's suppose this is a normal phenol, which is a common thing in para NO2 group connected A, right? I hope you know where which effect like which kind of effect is going to you can say apply. So it's a meta, and this is going to be the ortho. Okay, this is going to be the ortho one NO2, and a phenol will be like at the very end. So in this case, that is this is my phenol. So like it's a, it's a B, it's a C, or it's a D, right? So now understand, try to understand in this case. First of all, that in this case, you will be having only minus M, right? Maybe you already know that if let me just explain to you. if you will be having a benzene, okay, this is a benzene. So at this is some substituent at ortho position, which effect is going to participate? Inductive effect, hyperconjugation, or mesomeric. All three factors going to participate here. At meta position, only inductive effect, only inductive effect, no hyperconjugation or no mesomeric simply there. Only I have to be there. Okay, on the other hand, if I'm using para, so at para, hyperconjugation can be work or mesomeric can be work. Okay, so look at this, that if you're moving from there to there, ortho to meta to para, so inductive effects start decreasing. Even at para, there is a no inductive effect. Why? Because inductive effect is a distance dependent effect, right? So, according to that topic, logic, at this position only minus I effect, right? Only minus I. And at this position, if you are going to compare simply that this position, there is a minus I as well and a minus M as well, right? So, according to the topic, I'm going to say, wait. Okay, so in this case, we can say simply that is the C is going to be the maximum, right? Okay, like according to you, C is going to be the maximum. Why? Because minus I and minus M have to be there. But just try to understand. Okay, see, this is the last one. If you have to compare between the meta, like B is the last one, like D is the last one. D, why? Because in this case, no electron withdrawing, so D is the variant. And then B be like, okay, inductive effect. But between C and like A, which one is going to be the maximum? So the topic said that I have to select I have to select C over the B, right? Because in this case, there's a two effect, and this is going to be the correct answer. But why? Why not? This is the correct order. You know the real order or the real concept here, that is A, then C, and then B, and then D there. Okay, this is the actual answer have to be for this question. But how this is the order simply there? So this is the simple question for you. Okay, let me just write that this orthonitrophenol. So what is the extra factor here? Try to understand. In this case, if this is a OH there, okay, and this is NO2, you know, it's orthonitrophenol. So in this case, what is happening? Intramolecular hydrogen bonding. That is, this H is participate in a intramolecular hydrogen bonding. Okay, it's participate in a intramolecular hydrogen bonding. So now if we be like, you are going to give the hydrogen, this be like, no, my hydrogen is participate in a hydrogen bonding, why I have to give? Then para one be like, not an issue, I can give you, you can take me. Okay, you can take my hydrogen simply. So means simply, what is the reason behind this? That here you will be having hydrogen bonding, and that's why the correct answer for this question be like A, then C, and then B, and then D. Okay, I hope this question is clear for you, that how to select between every point. Okay. No, ortho effect is not there. Ortho effect is only present in carboxylic acid, Darshana. It's not present in phenol. Be noted, everyone. Ortho effect is only in COH group or in the carboxylic acid. Be noted. Okay, not apply that ortho effect everywhere. Right? So any issue with the order? Any problem with the concept? Okay then. So next question, please. Between same, that is between para-nitrophenol and this ortho-nitrophenol. In which case we are having maximum boiling point, or which one has a maximum boiling point? Ortho-nitrophenol, para or ortho. Question is this, that boiling point order. Let's say this is A or this is B. Which one has a maximum boiling point? Para. So yes, you're right, that is para. Reason is again what? That is the hydrogen bonding present this. Okay, so this is a very frequent statement maybe if you are solving the PYQ. So what is a not for this point here? That is ortho nitrophenol. Ortho nitrophenol is steam volatile. Okay, it's a steam volatile, or you can say react with a simple steel, sorry, not steel, steam. Okay, that is a steam volatile. Why? What is the reason behind this? That is the intramolecular hydrogen bonding. So do you know that if you want to differentiate between para or ortho, so this is the test. It's a pot, like kind of test that applies some kind of steam of a water. And okay, if that evaporation is there, so confirm it is a orthonitrophenol, otherwise it's a para. Okay, maybe you're not getting, ma'am, how it is a steam volatile. So try to understand again that, look at this is my orthonitrophenol. Okay, so these are the two molecule. Same, it's a ortho, nitro, and phenol. And on other hand, that is this is para nitro phenol. Okay, so there is a bonding between the molecule. So we are going to break, right? So in this case, this molecule break. No, I'm not going to participate. A one and two, you can say both are single single. There is a no bond between one and two. So what are we, actually what we are going to break if they are not even participate in hydrogen bonding? Yes, some different bonding like polar bond or like polar polar interaction, some interaction can be there, but hydrogen bonding is not between them. So if there is a no bond, so obviously the bond is very weak and easy to break. Even the steam evaporate the orthonitrophenol. But on the other hand, in this case, there is a attraction between them, so difficult to break. Okay, I hope this statement is clear for everyone. Now let's see the second point. So in the R OH bond breaking, we just discussed about acidic strength of alcohol and phenol. Now the third reaction in the same point, that is a reaction with metal. So if you are having some metal, so let's see how it is going to participate. So it's a reaction with metal. If let's suppose you will be having some metal, so it's simple still case, right? If let's suppose I'm having ROH there and there's some metal, let's say sodium. So what is it acid and what is it metal? That same typical reaction is going to happen, but we are getting, that is we are getting RO negative and Na positive, and simply what? H2 gets released, right? So simple, like normal acid base reaction, okay? Yes, you're right, Darshana. That para one has a inter and ortho one has a intra. Okay, so this is how you can say. Now, okay, this is all for the reaction of metal, and the same you can go with the phenol. Okay, so if let's suppose we will be having some phenol, RH, the same Na you are going to use, and then simply that if you remember the dough process kind of thing, and okay, that again H2 gas releases there. So this is all for the like ROH bond. Let me just quickly give you a brief what we just discussed. In the ROH bond breaking, we discuss about acidic strength, okay, or the second one, that is a reaction with metal. Okay, that's it. This is the first point done now. Now let's go with the second point, that if the bond between R and OH is going to break. Okay, so now that we are going to discuss about the second point, that if the bond between this ROH is going to break. Okay, so let's continue with this topic now. So let's start. This time we are going to break the bond between that this ROH. Simply this bond we are going to break. So in this, which type of thing we are going to discuss? Wait, let me just write. Okay, wait. One more reaction we are left. Just wait. In this one, we are just left with one more esterification. Okay. After this, we are going to discuss second one. I'm sorry for this. I forgot about this. It's esterification. So first of all, what is esters, right? So ester is what? That ester is nothing. Let's just write like this. Okay. CORO. So it's a ester. Or I can write that is RCOR. Okay, so both are ester. It's not like this is the only ester. So we are going to form the ester. You know that if alcohol is there and if carbonyl group is there, so they are combining. Okay, yes. So they are combining and we're getting ester. So let me just give you a general reaction, like actually what is going to happen. Okay, so what is the general reaction simply there? So you are having some ROH bond, okay, some alcohol is there, and then some RCO. Okay, let's say this is some Z group. I will tell you what is G, just wait for a while. Okay, so what is going to happen in this case? This G, okay, this G is go with this, like we are, okay, B noted. This is a like very, really very much important, like which bond is going to break. Just wait for a while. I will tell you the consequence, like why I'm using this, that it's a very important. So this GNH is going to participate, okay, or like, what, how about the reaction there? That there's a formation of ROCOR is there. Okay, so this is the product we are getting. Wait, this is the product we are getting. So this is normal esterification. So with the help of alcohol, you have to start with alcohol, and then at the end we are end up with the ester. Now the question, what is this G? So this G can be anything. For example, if G is H, so it's become acid, right? Carboxylic acid. If this G is chlorine or any halogen, let's say, so it's become acyl chloride, right? Like this. So it's a acyl chloride. Oh, I'm sorry, I'm habitual for this. So it's going to be the X. Or if this X is going to be, or this G is going to be the, let's suppose COCOR is there. So what is it? It's anhydride, right? It's a anhydride simply. So these are the three things. G can be OH group or carboxylic acid. G can be the RCOCl part, or G can be this. So you can simply say that whenever alcohol is combined with acid, carboxylic acid, or with acyl chloride or with anhydride, so we are getting esters. Okay, so this is a point number one. Now let me just explain the use of this ROH bond breaking. Okay, so this is a question, basically just try to answer the question. Okay, you are having some ROH. Okay, let's suppose I'm using 18 oxygen isotope. Okay, and this is going to react with RCOH. Okay, this is the simple thing here. Now you have to identify what is the final product. Okay, so we are discussing about the esterification, so you have to identify that. Let me just add some acid kind of thing. Okay, so you have to simply identify, or let's not mention right now. Okay, so you have to identify the product number one. This is the correct product. Sorry. Okay, let's just use some RDS. Okay, RDS. Okay, just let me know between A and B. Okay, so which one is the final product here? Okay, hi. What is real name? Yes, please. A. Sorry, B. Okay, so it's look easy right now, right? Because ma'am, you just discussed like it's a type of ROH bond. But when the same question asked in exam, so what is the problem? Like, okay, we just we used to remember this, like there is a formation of water and quickly that release the water molecule. It's a shortcut, and okay, they're going to combine. Okay, but what is the biggest problem? Like, should we have to consider this O is the part, or like you have to consider the water molecule release like this? Wait. Wait, I'm explaining this here. So there's just two choices. The choice number one, that are CO and OH. So what is the choice number one? Let's form the water from this combination, right? So this is the combination one, water molecule release. Or the second combination, that if let's suppose I'm having ROH and this is my R, CO and OH bond is there. So why not I can form the water from there? Because what we know, that in esterification acid and alcohol is going to combine, water molecule is an ester form. But how the water molecule form, this is the important point. So be noted, it's really very much important there. Now let's start with the esterification, like how to form the ester and all these things. So let me just give you some kind of reactions. So first of all, let's see if you are having alcohol. Okay, let's just do what, let's make a chart and everyone just mention there. So you will be having some R, O or H. So first of all, I'm using R, CO and OH. And in this case, it's an equilibrium reaction, be noted. Okay, okay, like this is a equilibrium reaction, and then you will be getting a ester there simply. Okay, and still water molecule release like the previous one. Or the second one, that same, if this is going to participate with this RCOOCOR again. Okay, so in this case, that ROCO and R. So can you just tell me what is the side product as well? Because side product also has importance. Memory loss. Yes, please. What is the answer? What is the side product we're getting? You know the reaction, right? You know the basic thing now. RCOH. You mean to say carboxylic acid, Darshana, right? Okay then. So in this case, if we are observing, like this is a ROCOR group, right? So okay, that if you can say that it's a C. Oh wait, that it's a O, and this is H, right? So this portion is combined. Okay, like this. So what is this? Nothing. Normal or carboxylic acid, right? So it's not like B naughted. Now water we know in ester water is the side product. No, it can be changed with the reaction. Okay, so this is how you're getting a normal acid have to be there. Okay, so let me just erase this. Simple that there is a formation of acid. So how about the acid RCOH? Now my next question to you. What if I want to increase the rate of reaction because it's a equilibrium reaction? So how to achieve? How to increase the rate of this reaction? Apply the Lee-Chatelier principle. Remember everyone? So in this case, that if you have to remove the water, right? So in this case, if I'm removing the water, let's suppose water forming and you keep simply removing this. So if you have to remove the water, so Lee-Chat will be like you're decreasing the product side. So let's move, okay? So this is, it is going to be the helpful for us that equilibrium reaction, and even we are able to handle the yield of the product as well. Remove the water continuously and we are end up with ester, 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 ester again and again and again. Okay, this is all for the esterification point here. Okay, so let me just check more important point here. Oh, one more left, right? Acid chloride one. So the last one are CO and Cl. Same question first of all, what is the side product again? Let me just write, okay, we are going to get acid, but what is the side product? Options are like increase the reactant. But if you're increasing the reactant, Darshana, then it is going to be the backward, right? No, you will get the product, right? Okay, yeah, you can say, but like very good thing, like in a small, let's suppose I'm having less amount of reactant, then how to increase the yield, okay? So just increase removing the water and in the same reactant or the same kind of reactant concentration, we are having more product now. So yes, please answer this question. What is the side product again? RCL? Okay. So let's try to understand. Right. So again, I'm having ROH and this is RCO Cl there, right? So what is it? Darshana, HCl. Okay. So in this case, we're getting HCl as a side product. Okay. So everything is really important here, like side product and all this thing. So in this case, we are getting extra thing that is HCl as well. So normal sorted HCl is there. Okay. Now let's start with the next one that what we're discussing there, that ROH bond breaking. So let's break this ROH bond now, okay? So let's discuss about this reaction as well. Wait. Okay, one more important point here. In this case, okay, let me just highlight this. Okay, this last one. Okay, in this case, let's write a kind of note because you know sometimes statement-based question also ask like a rational reason. So in this case, if alcohol combine with acid chloride or acid halide, let's say. So in this case, we are added pyridine. We are added pyridine. And I hope you know what is pyridine. This is the pyridine. Okay. So Why? To increase the yield, to shift equilibrium toward product side. But now my question to you, how? I will explain. With the addition of this, pyridine, okay, you can increase the yield or shift the equilibrium toward the product side. But how? What is so special about the pyridine? Yes, very good, Darshana. So what is the problem with the reaction? That in this reaction we are getting, okay, this is ROH and it is combined with R, CO and Cl. So what is the extra point in this reaction if you're observing? That again equilibrium, and in this case that CO and R and plus HCl there. So pyridine be like HCl, just come with me. So pyridine form a complex, okay? Like this is a hydrogen chloride. So you know ammonium chloride kind of thing formation. So this kind of complex form, it start consuming the HCl, and just because of this, again, what is happening? In the first one, we are removing the water, and this time that you can simply add a pyridine, it start consuming the HCl, and automatically the reaction shift in a product side. Okay, so let me just add one more point between this, that if you to add the pyridine, neutralization take place. Neutralization of HCl, okay, and then shift the equilibrium toward the product side. Okay, this is how you can simply remember. It's again important for acceleration or a reason kind of reaction there. Okay, so this is all for the ROH. So let me just check like it's enough. Okay. Now let's see the ROH part there, okay? So in this case, we are going to discuss so many reactions in the next class. Just one reaction we are going to start in today's class, okay? ROH part there. So in a ROH part, the first type is the reaction with hydrogen halide, okay? In the second one is what? With phosphorus halide. Okay, so first of all, we are going to discuss these two part. There's so many reaction like that oxidation reaction as well. Let me just write, okay? Oxidation reaction. And the last one is what? Miscellaneous. Okay, so don't worry, we are going to cover each and every point. Miscellaneous reaction. Now, this is the only topic which we are going to discuss now, and you will tell me what is it. You are having some ROH, and I'm having some hydrogen halide. So let's say some HBr, let's say. So what actually I'm getting? Yes, please answer the question. You already know this type of reaction. What is it? Hmm. Come on, just do this. Okay? Okay, wait. Let me just write like this. And this is H positive. You know what is it? Acid. Then what is the name of this reaction? Or what is this? We discussed this thing in the previous class as well, or in a reaction mechanism as well. What is it? Something click in your mind right now? What is it? No. Okay. So in this case, yes, RBR is there. Actually, I want to ask the name of reaction, by the way. Yes, dehydration. Yeah, you're right. Dehydration have to be there. Okay, so although you're at HBr and water, HBr and water, so yeah, let's try to understand. The toxin has a lone pair, it's attacked there, and then positive charge there. Okay, and then some Br added, and then we're getting RBr. So yes, very good for the product side. That what will be the final answer here? That you will be having RBr and water is there. So what is this? So this is a like maybe in NCERT it is written as a separate topic. That is a dehydration of alcohol. Okay, or the removal of water. Dehydration of alcohol simply. or leave it. Okay, I will explain this next. Okay, just consider this, that in this case what we are getting hydrogen halide, first point. Now, what is the rate of reaction? Like if you are having tertiary alcohol, primary alcohol, or secondary alcohol. Let me just read the question properly. Question is this, that what is the order of reaction in in reaction of alcohol with HCl? If you are having tertiary alcohol or primary or secondary, just let me know simply, okay? This is my question. Tertiary alcohol, primary alcohol, or secondary alcohol? What will be the order? Yes, please. What is the order here? You already know the mechanism. I guess it's easy, right? Very good. It's the tertiary, secondary, and primary. Okay, so what is it? This is simply that formation of carbocation is the rate determining step in this case. Okay, RDS step. So what? Obviously, the correct answer is going to be the tertiary, secondary, and primary. Okay, this is all for the class. In the next class, we're going to discuss about the left portion and one more you have to add it. That is a dehydration. And dehydration, you already know. If you want to answer this, otherwise, although we are going to discuss, but still. What is this? You already know. Like options are substitution reaction, elimination reaction, or what is it? No, no, Darshana. Yeah, if it is a SN2 mechanism, then it is going to follow primary, secondary, and tertiary. But here we are going to follow the, formation of carbocation is the key point. Okay, so that's why in this case you have to follow the tertiary, then secondary, and then primary. Okay. Most of the time, that is a dehydration of alcohol with the HBr is follow this mechanism. Okay. Why not SN2? Yeah, you can go with the SN2, but you have to use another reason then, okay? For SN2, we're requiring a strong electrophile, strong nucleophile then. Okay, you can change the condition so it starts shifting toward that, which primary or secondary or tertiary. Yes, please, dehydration of alcohol. Options are elimination reaction, substitution reaction. What is this? Anyway, this will be a HW for you, right? Now let me just take the doubt of Darshana, okay? This is all for the class. If you're not having any doubt, so you can leave the class, okay? If you are having any doubt, so first of all, welcome to the doubt part now. Any problem, first ask, please. Okay? Yeah, I'm taking your doubt, but let me just check it. Any doubt for the topic? So please revise the GOC part. Yes, answer is going to be the elimination reaction. You're right, Darshana, okay? So, what is your doubt? So your question will be like SO2, SiO2, P2O5, and Cl2, right? Let me just write. Your question is like SO3 or P2O5, right? Or the Cl2O7 or SiO4. Am I right? SiO2, okay. Okay, so first of all, your doubt be like that. I guess according order is this Cl2. Let's just check A, B, C, or D. So according to your reference, you said D, then A, and then B, or then C. This is the correct answer according to your reference, Darshana. Am I right? HCl question. Okay, wait, Dishika. I will explain first, okay? You are having ROH, okay? And then RCOCl, okay? First of all, please respond this one. You are referring, Dishika. Please respond. Which one you are referring? Okay, then, wait, which slide? This one? Reverse order. Previous. Sorry, I'm not getting like how you're saying reverse order. Okay, why? Okay. So let's suppose I'm having tertiary alcohol, okay? Carbon combined with 3 CH3 group and water molecule. Secondary water molecule, sorry, like this. I'm sorry. It's a CH3 and OH. And how about the primary? Okay, like this. In all three cases, that is a protonation simply. Okay, this one is going to leave, this one is going to leave, like this. Okay, so in this case, we're getting this is the carbon and this is the carbon or this is the carbon. And now you will tell me which positive charge is more stable, Dashika. Okay, Darshana. Okay, Dashika. So in this case, if you're observing the tertiary one, so look at this. That is a 1, 2, and 3 CH3 group. And in this case, 1 and 2, 2 CH3 group. And in this case, only 1. So in this case, you are having 3 electron donating group. So that's why this one. And in this case, that is a 2 electron donating group. And in this case, only 1 electron donating group. So definitely this is more stable over the secondary or the primary. Okay, Dashika. So I hope it is clear now. Okay. So now, like Dashna, this is your question, this is your doubt, right? So let's just try to understand first of all. Okay, like whatever you are referring, okay, I don't know like where you picked this question, but it's not the correct order. Okay, like I can admit, like if you are comparing between the Cl2O7 or like P2O5 in this or between these two, like if you are comparing, so you are saying P2O5 is the maximum one, right? So in this case, this is a like maximum over the Cl2 there. But still, like how you are saying between this and this, how you're comparing, because both are the normally the zero as a dipole moment. So according to me, let's just suppose if you are comparing, SO3 is the one of the famous, it's a trigonal planar geometry. And I hope you already know in this case that one dipole moment like, one dipole moment like, one dipole moment like, so obviously the mu is going to be the zero. And on other hand, like if you're observing this SiO2, so it's also a diamond kind of structure. Okay, like SiO2, it's a sheet if you remember, 3D sheet like this. Okay, so according to this topic again, that is for this one, the dipole moment is zero. Okay, this is the point number two. And then if you're comparing the P2O5, so phosphorus, five oxygens, this is the P2O5, and Cl2O7, so chlorine. Okay, so in this case, like if you want to say, like in this case, this is a bent, right? This is a bent shape. This is also the bent, the center one. So if like let's suppose you're comparing the dipole moment for this and this be like this, and between oxygen this is like this. So how? It's not possible. Like in this case you are having zero. So wait, that all the dipole moment pointing in the same direction. Look at this. So in this case dipole moment can't be zero, and in this case again that again because oxygen is much more electronegative over the chlorine. So again that is all three are pointing in the same direction. Okay, so all three are pointing in the same direction again. So in this case again, that dipole moment is not going to be the zero. But between this first and then, it's not going to be it's not possible. Okay, ortho para tendon. So then what is going to happen after that? Yeah, if let's suppose maybe you are saying, ma'am, you know, like you can say like this is zero. If this is zero, let me just explain what I want to say. That if let's suppose this is the P2O, sorry, it's a PO2 or it's a PO2, like this. If you are saying, and you have to consider this is like which one linear there. So like this one you can say dipole moment is going to be the zero, right? So but still no. Okay, we can say like between this and this the band structure have to be there. So it can't be zero. Like if you have to go with the option, I'm explaining like how you can say that option is going to be the correct or the answer which you are referring is going to be the correct. Okay, so electron electrode difference of course have to be there. Okay, OP Tandon. Okay, I don't know about the book. It's a some foreigner book. Just do what? Let me just send the book. Okay, I will check because according to me, it can't be possible. You know, it's like you to digest the thing because maybe then they are mentioning the problem be like let's suppose this is a Q, Q is going to be the Q into D, and then they can apply that okay dipole moment concept. Like in this case, this is a single bond. Okay, so dipole the bond is not that much strong, and in this case you are having a double bond. So like logically that single bond wise Si2 has a maximum one. Okay, then P2O5, like if you are comparing the bond, so in both the cases there is a single bond. Okay, so bond length wise both are max more than SO3. But you know, like it's be like we know the answer and we are just proving okay that answer is correct. Okay, Darshana, according to me, whatever you are asked, like this is not logical. Like how an SiO2 or like this SO3 there is a diplement have to be there because it's zero. It's definitely zero because we know that complete tetrahedral or like perfect tetrahedral, perfect octahedral have a zero as a dipole moment. Okay, but yeah, you can say electron activity difference wise, maybe there's a little bit difference, but no, it's not. Actually, according to me, it's not the correct answer. But again, just send me the book reference. I will check like what is the problem. Or maybe we're missing something. Because in 12th class, this topic is not anywhere, Darshana. Okay. So actually, so listen my point. For 11th and 12th, follow the NCRT, follow our modules. You already have the ebooks. It's enough for you. Okay, if you are referring like that is very high tech book, so trust me, JEE main level is not that much high, Darshana. Okay, so try to solve the basic question first, and again just send me. I will try my best if I know the answer. Okay. So anyway, thank you then. Thanks for joining the class, and okay, have a nice day, everyone. Thank you so much.